Hey guys, I just wanted to go over a couple factoring techniques with you in case you were forgetting them or you needed to see them when you're doing your homework tonight because they're definitely going to be usable and I don't want you having to use your P's and Q's unless you have to. All right, so in your homework tonight, they're going to be asking you to graph the polynomial by first factoring and then using your analyzing techniques. So I just want you guys to understand that when they say to factor, P's and Q's does count as a factoring technique, so they do mean to use P's and Q's. And if you were to view an example, they may walk you through the P's and Q's process for a problem that may not need P's and Q's. So I think it was a problem like this on the homework where they had you using your P's and Q's, your rational zero theorem. But guys, this factors, so you don't have to go through that process as long as you can recognize the ones that factor. All right, so this is one of those even degree polynomials that is not a quadratic, but it'll factor like a quadratic, right? So if I'm going to factor this, I would look for a GCF. It doesn't have one. It's a degree 4, but it's an x to the 4th that has an x squared in the middle and then no x's. So when this term is half the degree of that term, that's one of those special even degree polynomials that's going to factor like a quadratic. So guys, they're going to walk you through a P and Q process if you view the example, but all you have to do is factor this and you can get your zeros and start creating the graph really, really quickly. All right, so if I notice, like I said, there's no GCF, I would go right to creating two factors. What times what will get me an x to the 4th, but still allow my rainbows to get me an x squared in the middle, an x squared and an x squared, right? And then what and what will multiply to negative 18, and then what will make my middles add up to negative 7x squared. That's a negative 9 and a positive 2, right? That'll add up to negative 9x squared and 2x squared. That gets me my negative 7x squared, and that gets me my negative 18. So you factored it without having to use P's and Q's, okay? So now if you notice, if they ask you to factor completely, this is the difference of two perfect squares. So that's going to factor again to x plus 3, x minus 3, and x squared plus 2. So now you've factored it completely, set all your factors equal to 0, and you can find your x-intercepts on your own. We're going to have an x-intercept at negative 3, an x-intercept at 3. If you set x squared plus 2 equal to 0 and solve, you're going to minus 2, and you're going to get x squared equals negative 2 square root. You're taking the square root of a negative number. You're going to get x equals plus or minus I root 2. You're going to get an imaginary 0 here, which is not an x-intercept, so they don't even count. So all you'd have is negative 3 and 3 as your zeros, right? They're going to ask you to find the end behavior, which end is up, which end is down. They're going to ask you to graph it, find the y-intercept to get your turning points using the calculation on your graphing calculator for the max and mins. They're going to ask you about the multiplicities of your zeros, and then they're going to ask you to write it in factored form, but you've already got it in factored form by factoring it, all right? So this is what that you can do instead of having to use your P's and Q's. And then when you go to create your graph, right, you just put your zeros on the graph. I think they're going to make you graph it online, which is easier. All right, you got 3, you got negative 3. They each had multiplicity 1, so they are just straight crossover points. They're not bounces. They're not going to flatten out or anything like that. They're going to cross over like normal. All right, and then it was a degree 4 with a positive leading coefficient. So it's going to be both up on the end behavior. And then it's probably going to look something like a parabola, even though it's not a parabola. There might be some more peaks and valleys in here because of our imaginary zeros, but that's it. You've created everything you need to create and found everything you need to create without having to go through the P's and Q's process. So I really don't want you guys to have to do that unless you have to. All right, so don't forget factoring techniques. All right, look at this one. Right? Same type of problem. They're going to ask you to graph the polynomial by first factoring, right? So you're going to look, oh, it's a degree 5. Maybe it doesn't factor. If you viewed the example, I'm pretty sure they walk you through your P's and Q's. But guys, yeah, it's a degree 5, but it's 4 terms. So it looks like it might qualify for a factor by grouping. So don't forget, there are ones on your homework that factor by grouping. So I would try that first. If you're going to factor this by grouping, you group the first two, you group the second two. Now I look at these two terms only. I'm looking for their GCF. Well, their GCF is a 4x to the 4th. So take it out. That leaves me with x minus 3. All right, now I look at these two. I look for their GCF. They don't have one, but everything has a GCF of 1, so I can at least pull a 1 out. And with factor by grouping, you always have to pull that leading sign out. So I have to pull a negative out, and then their GCF was 1. So I have to pull a negative 1 out, and then that's going to leave me with what? An x and a minus 3. And factor by grouping only works if you end up with that common factor in the middle there. And I do. I got an x minus 3 and an x minus 3. So factor by grouping worked. So that means my factors become the one that matched, x minus 3. And then my other factor is, who did I factor out? 4x to the 4th minus 1. So 4x to the 4th minus 1. All right, and now if you notice even more, considering we're trying to factor as much as we can, this is the difference of two perfect squares as well. So I can factor that again. X minus 3 comes down. This factors again. What times what gets me a 4x to the 4th? A 2x squared and a 2x squared. What multiplies to negative 1, a 1 and a 1, and then my middles have to add up to 0 x squareds in the middle. That's going to be a positive and a negative. Right, the difference of two perfect squares. So now I have all my factors. So now I can set my factors equal to 0, and I would get x equals 3 is one of my x-intercepts. If I set 2x squared plus 1 equal to 0, I'm going to minus 1 and divide by 2. I'm going to get x squared equals negative 1/2. But when I take the square root of a negative number, I'm going to get imaginary zeros. So they don't count. All right, and then I set 2, because right now we're only finding the real ones. 2x squared minus 1 equals 0. I'm going to add 1 and divide by 2. I'll get x squared equals positive 1/2. So now I can square root a positive number, and I'll get x equals plus or minus. The square root of 1 is 1 over, I can't take the square root of 2, and I can't reduce it, and then I'll just rationalize it by top and bottom multiplying by root 2. So you end up with x equals plus or minus root 2 over 2. And those are 1, 2, 3 of your zeros out of the 5, because 2 of them ended up being imaginary. All right. And then you could just start plotting them, right? You'd have an x-intercept at positive 3, positive and negative root 2 over 2. That's like 1.4 divided by 2. That's plus or minus 0.7. So you'd have positive 0.7 and negative 0.7. Your end behavior is based off of 4x to the 4th. So that's an odd degree with a leading coefficient that's positive. So that's up on the right and down on the left, right? There's no multiplicities, right? Everything is a single multiplicity. So everything's a straight crossover. There's no bounces. There's no flattening out. So I would look like that. And then you'd have your graph to go off of, okay? So again, I just wanted to go over those factoring techniques so you don't miss them, so you don't end up using P's and Q's when you don't have to, okay? And then also, there's one problem on your homework that is meant to be pretty easy, and I don't want you guys to get confused on it. I think it asks you, given a polynomial function, find the zeros of f of x plus 3. Well, guys, first you'd have to find the original function zeros. It looks like a p and q to me. It doesn't look like it's going to factor by grouping. So you'd probably have to go through the p's and q's process to find the zeros. But the good news is it's a degree 3. So after one round of synthetic, after finding one of those real zeros, you'd be left with a quadratic that you can either factor or get the quadratic formula to get your last two zeros with. All right. But I want you guys to remember, this is asking you for a transformation. If this is the graph of f of x, then the graph of f of x plus 3 is a transformation. So do you guys remember, if the 2 was on the outside, that affected y. So this would be like the y's plus 2. So this would move the graph up 2. This is like the y's subtract 3. So this would move the graph down 3. This would be inside, so it's happening to x, but the opposite effect happens to x. So if it's x plus 2, it doesn't go right 2, it pushes the graph left 2. All right, and then this one, the graph of y equals f of x minus 3, I am inside affecting x, so it's a horizontal transformation. It says x minus 3, except the opposite would happen, so it doesn't go left 3, it bumps the graph right 3. So if they want the graph of what are the zeros of f of x plus 3? Well, f of x plus 3, I'm inside adding 3 to x, so it's a horizontal transformation, except it's the opposite. It moves the graph left 3. So are you okay? Yeah. All right, it moves the graph left 3. So you would just take all of the original x-intercepts that you found, and you would move them left 3. Subtract 3 from the zeros that you found. So let's just say you found out it had zeros at -2, let's say 1, and let's say 2/3. All right, just subtract 3, get -5, subtract 3, and get -2, and then take 2/3 and subtract 3 and get your last 0. All right, so it looks kind of difficult, but it's just a transformation question. Just find your original zeros and then make this transformation to them. Okay. All right. I hope that helps. If you needed to see it, as always, reach out to me with any questions that you might have.
Are you done?